CLI and a cross-platform IDE for C and C++. Download now.
Hello, this is performance. It's not a comedy, it's not a documentary, it's probably some thriller or maybe some horror. So let's get it down to it. So, do you use Quicksort? Why are you using Quicksort? Performance, right? Why don't you use bubble sort? Like, it's simpler. Like, you can just use bubble sort in your daily work, right? Or Bogus sort. You just repeat one until sorted and just randomly shuffle your data. We can use that if performance was not a concern, but there are a lot of people that says performance is a concern. So I wondered, like I always do, what if performance was not a concern? What would be the world in which we would live on? Like, simply not a problem. We could never think about performance. How would we design our database? Like, why don't we use a singly linked list and just store everything on magnetic tapes? It's not a performance concern. We can do that, right? We can put everything in a linked list. Well, it turns out that if performance is not a concern, I do have one algorithm, the algorithm, that can solve all the problems if we have an acceptance function. And probably I should patent this because it's the algorithm. So assuming I have that solution is valid function that is generated by the user, we can write this the algorithm that is always correct. Like, I can put a contract assert that the solution is valid, the solution that produced by this algorithm. And actually, the algorithm fits on one screen. It's not that hard. So I have the check solution is given to me, and our algorithm is something like that. I initially put a solution with 0 bits in it, and I keep adding bits. And each time I add bits, I go through all the permutation of those bits, and I can just try out different solutions, right? Just backtracking all the way through, and just keep increasing bits. If my problem has, I don't know, 1 million bits, there's not a problem. We don't have a performance issue. We can generate all the permutations for 1 million bits, right? That works, right? You're convinced it works. So if there is a solution to the problem, to any problem, my algorithm will find it. Well, of course, there's a problem with my algorithm and, of course, the Lucian taxonomy. There are S programs, P programs, and E programs. The S programs, are the programs that goes from a specification to a solution. So that means if I have a specification, I can use a test function, that's fine. P programs are like chess programs. From the specification, you can't go to a solution. You have to have something else that tells you whether that solution is good or bad. You can't go from the rules of chess to playing a good chess game. Then E programs is with feedback loops that involves humans and all that, which are more complicated. So for S programs, we have the algorithms, but can we put something in place of P programs and E programs? Well, it turns out we can. We can write this solution is valid and just ask a person, right? Because performance is not a problem, we can always ask a person. So if somebody comes to you and tells you that performance is not a problem, hire them for this job, right? That's a pretty good job. And I think by now I convinced you that performance is always a problem. It may not be your immediate problem, but it's always a problem. That's a pretty scary story. Thank you very much.